Hello everyone, welcome to Real Science Challenge. I'm Kent Louie, science teacher and talking head, broadcasting from beautiful Vancouver, Canada. As science teachers, we have students produce graphs all the time. But how do we mark them without spending too much time on it while still maintaining a high standard? So today, I'm sharing how I use proficiency scales, specifically a one-column rubric, to mark graphs a little bit more efficiently. But before I continue, handouts for this episode can be found at realsciencechallenge.com/EP47. And please subscribe to our YouTube channel. Now, here's a graph a student produced recently. Now, what would you give them as a mark? Or better yet, what would they receive as a mark? Now, I think we all start marking graphs from the same place. We use a checklist, and we assign or remove points based on what's included in or missing from the graph, based on, of course, this checklist. Now, this is a great place to start. But the thing is, more recent science curriculum, like the NGSS, Next Generation Science Standards, is grounded in proficiency of science skills and not just content. And using numbers, like a scale out of 10 or 20, is a very inefficient way to communicate proficiency. For example, if a student gets, let's say, an 8 out of 10 on a graph, and another gets 9 out of 10 on a graph, aren't they both just as proficient? It's like a student who gets 75% on a test and another who gets 76% on a test. I mean, practically speaking, there's very little difference, if any difference, between those two students. So, why go through the whole exercise of tallying up individual points and computing a score out of 10 or 20? Why not just say proficient? It seems faster to me. And therefore, here in British Columbia, we use a proficiency scale of emerging, developing, proficient, and extending to assess a student's proficiency at a skill, as opposed to using numbers. So, when it comes to marking a graph, I'm starting to use a one-column rubric. That is, all the items that make a graph proficient will be at the proficient level. If a student doesn't hit these items effectively, then they're developing or emerging. If they're able to really dive deep into a graph, well, then they're extending. But the key thing we need to stress is that we want all students to be at the proficient level. This is why the proficient level is all filled in. But first, I need to decide what proficient looks like. And here's my list. They have to be able to use the correct graph type, whether it's line graph or bar graphs. They have to label the axis with correct units. They have to graph maximizing the space. I say 75% of the paper or more. The graph needs to be neat and legible, and the graph must be accurate and matches the data. Now, you're probably wondering, why isn't extending bubbled in? Well, because the point is not to get to extending. The point is to get to proficient. So, going back to this graph right here, I'd say this graph is probably developing. It's not really maximizing the space here, and the labeling could be a little bit more clear. It could be a little bit more neat. Now, you're probably wondering, what about this extending part? What does that look like? And this is where it differs between each colleague. To me, extending is really when you dive deep into the details of a graph. So let me give you an example. Let's say this is some data you want to graph. Now, this is the y-axis, this is the x-axis, and notice it is a maximum of 33 on the y-axis. And let's say you're given this graph with like 15 lines on it. Well, how do you represent this on this graph? I mean, here's one way of doing it. You could make every line equal to 2, but the problem is you would run out of space, because remember, the maximum is 33. You could try, maybe every line is worth 3, but then you're not really maximizing that graph. So maybe you can, maybe do this. Maybe you try to make the 15th one out of 33, and then everything else will, and then of course every few are out of 11. And this is where you maximize the graph. And this is kind of something I learned in university when I got there, producing big graphs, and something that I think students deciding that scale is probably going to be quite challenging. So therefore, I think that's an extending mark. Other things that colleagues have suggested, find the line equation, the slope, without me telling them. That might be part of that extending piece as well. That's it for this episode. Please smash the like or subscribe button or leave a comment below. And handouts, once again, are at realsciencechallenge.com/EP47. Thanks for watching, and let's talk science again soon.